I was too lazy to download music, so this is what you get instead of an intro song. Hey guys, welcome to Lesson 10, the structure of ratio tables, additive and multiplicative. All right, so let's fill this table in. So it says, imagine that you are making a fruit salad. For every quart of blueberries you add, you would then put 3 quarts of strawberries. So let's fill this into table 1. Actually, we should probably read all the directions first. Okay, so create 3 ratio tables that show the amount of blueberries and strawberries you would use if you needed to make a fruit salad for greater numbers of people. So table 1 should contain the amounts you have added for fewer than 10 quarts of blueberries to the salad. Okay, so these numbers need to be less than 10. Table 2 should contain the amounts of blueberries between and including 10 and 50. So this is going to be 10, 20, 30, 40, and 50. And table 3 should contain amounts of blueberries greater than or equal to 100 quarts. So bigger, greater than 100. Remember, this symbol means less than, and this symbol means greater than. Okay, so greater than or equal to 100. So we'll go by hundreds. Hundreds, 200, 300, 400, and 500. Okay, and then here we'll just go 1, 2, 3, 4, 5. If you were to add fewer than 10 quarts. Cool. So 1, 2, 3, 4, 5. So remember, if we add 1 quart of blueberries, we're going to add 3 quarts of strawberries. Right? So if we increase this, if we multiply by 2, right, this is going to be 6. Okay? 3 quarts is going to be 9, 12, and 15. Right? So we find this number by taking the number of blueberries and the number of strawberries, and we can multiply this. This is like, if we have 1 quart here, we have 3. If we have 2 quarts, we got 6. And we can actually multiply 3 times 2 and get 6. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. So here we can do kind of a similar thing for table 2. So if we have 10 blueberries, well, we know that 10 times 3 is 30. So this is going to be 30. And 20 times 3 is 60. So the reason that we are multiplying by 3 is because this tells us how many we have for 1 quart, right? If we had 10 quarts, we would need 10 of these. If we had 30 quarts, we would need 30 of this many. So that's going to be 90, 120, and 150. All right, so if we went by hundreds, right, 100 times 3 is 300, 200 times 3, 600, 900, 1200, or 1200, and 1500, or 1500. So, describe any patterns you see in the tables. Be specific in your descriptions. So I'm actually going to ask you guys to do this by yourself in your note. What patterns do you see in these tables? Look at them. Do you see anything that is overlapping? Please write this in your notes. So A should go in your notes section. Okay, tell me what you see. B, how are the amounts of blueberries and the strawberries related to each other? So I'll do this one with you. The amount of blueberries and strawberries are related because there are always 3 times as many strawberries as blueberries. So we can just write this here. There are many as. How are the values in blueberries and the blueberry columns related to each other? Well, like here, we were increasing by 1. So we were counting by 1. 1, 2, 3, 4, 5. Here we counted by tens. And here we counted by hundreds. How are they related to each other? Basically, we can say like by how we counted. Okay. Now D says, how are the values of the strawberry columns related to each other? Those are like counting by 3s, right? So here, from here to here, we counted by 3. From here to here is 3. From here to here is 3. From here to here is 3. And from here to here, we're counting by 30s. Right, so here we counted by 10s. Here we counted by 1s. And here we counted by hundreds. So because of that, here we counted by 30s. And here we counted by 300s. How are the values and they're related to each other? They go up by threes, right? So here we go up by like threes in the ones or threes in the 10 here, like so they go up by 30s and then by 300s. Let's do E. E says, if we know we want to add 7 quarts of blueberries to the fruit salad in table 1, how can we use the table to help us determine how many strawberries to add? So we know that if we have 1, 2, 3, 4, 5 here, we already figured it out before, right? If we have 7 quarts of blueberries, there's 3 times as many strawberries. So we're going to do 7 times 3, which is 21. There are 21 that we can do there. The other thing that we can do is that we see that we already have 5 and 2, and we know that 5 plus 2, right? 5 plus 2 is 7. So if we're going to add these two together, 15 plus 6, right, is 21, which is the same thing that we got over here. So we can use the table to help us figure out, hey, if we've got 7 people, we can add this. So for example, here, if maybe we had 100 people coming to the party, we could add that. If we had 600 people coming to the party, we could add the 500 and the 100 amount, right? So that would be 600. Oops, 600, okay? And we could either multiply by 3 or we could add them up, and we would get 1,800 or 1,800. All right, F says, if we know we used 70 quarts of blueberry to make our salad, how can we use a ratio table to find out how many quarts of strawberries were used? Well, we could continue counting, or we could take 70, and we know that there's 3 times as many strawberries, and we get 2,100. All right, let's work on exercise 1. So it says the following tables were made incorrectly. Find the mistake that were made and create the correct ratio table and state the ratio that was used to make the correct ratio table. All right, so let's look at the hours first. So 3 and 24. So the first thing we want to do is see, okay, this goes up by 2, and then this goes up by 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. Okay, so just like we did in our first example with the blueberries and the strawberries, we knew that if one side went up by 2, then the other side has to go up by a same rate. It doesn't necessarily have to be the same number as the left side, right? Because remember, we had a ratio of 1 to 3 before, so each side on the left would go up by 1, and each side on the right went up by 3. So what I want to do here is go, okay, 24 plus 16 here. So that means if we went up by 16, then we should be able to add 16 to this. And let me fix that. I had the wrong tool selected. Okay, we should be able to add 16 to that. And this should be, we have a mistake, right? So here's where our mistake is. This number should be 56 because we're going up by 16s. So let's correct our table. 3, 5, 7, 9. We know that this number is 24, and it increased by 16. Oops, that should be actually 40. It increased, right, by 16. So let's actually figure out what our ratio is, and we're going to do this up here. In 1 hour, how much money do they make? Well, if we look at this table and what we know about multiplication, we know that 3 times 8, right? 3 times 8 equals 24. So because of that, that means that for every 1 hour, they make $8. Okay, so for 3 hours of work, they make $24. For 5 hours, 5 times 8 is 40. Okay, cool, that checks out. 7 times 8 is 56. Okay, and 9 times 8 is 72. So this number here was incorrect, right? This one was correct. And we can check that by seeing that our ratio is 1 to 8. So here what we're going to want to do is take our ratio and go 1 to 8. Another way we could have figured this out is taken this first ratio, 3 to 24, written it as a fraction, and find the value of it. So remember, the value of a ratio is you take the ratio and you reduce it to its simplest terms, 1/8. So here we have this ratio, right, as a fraction. We can now write this as a regular ratio, 1 to 8. And that means we can basically just multiply each side. So like if we did by 2, right, 1 times 2 is 2, 8 times 2 is 16. If they work 2 hours, $16. 1 times 3 is 3, 8 times 3 is 24, and here we have a ratio of 3 to 24, which is what we have here. All right, let's do the next one. Blue to yellow. So blue whatever to yellow whatever. So here you can see that this is going up by 3, right? And here this is going up, also by 3, okay? But we have a ratio of 1 to 5. 1 to 5. So if we want to make sure this table is correct, we do 4, right? 1 times 4 is 4. And 5 times 4 is 20. Because we know that our ratio is 1 to 5. So that means that this number should actually be 20 if we know that our first ratio is correct. So now if we do the same thing, 7, we're going to keep making equivalent ratios over here. 1 times 7 is 7, and 5 times 7 is, well, it's not 13, it's 35. 5, I don't know why I said 5. Okay, 1. 1 times 10 is 10, and 5 times 10 is 50. So there we go. So let's write our ratio table out correctly. If we have 1 blue something, we have 5 yellow something. So that means that if we have 4 blue something, we have 20 blue something. Okay. If we have 7 blue something, we've got 35 blue something. And 10 to 50. So we got to take the ratio, right? We need to write down the ratio. It's 1 to 5. If we write this as a fraction, we have 1 to 5, and here's the value of that function. Excuse me, of that ratio. Oops. Always. Ooh. Okay. Okay. So, lesson summary. Ratio tables are constructed in a special way. Each pair of values in the table will be equivalent to the same ratio. So here you have 3 to 12. This is our basic ratio, right? 3 to 12. If we write that as a fraction, we have 3 to 12. We reduce it 1 to 4. The value of this is 1 to 4. Same thing here, 6 to 24. We write it as a ratio. We reduce that ratio, we get 1/4. Here's the value. Same thing here. Here's the value. Okay. Repeated addition or multiplication can be used to create a ratio table. The values in the first column can be multiplied by a constant value to get the values in the second column. So here you have 3 times 4 is 12. If we took 3 and 12, like we did before, we know that this is the same thing as 1 to 4, which means that you have 4 times as many whites as you do red. So you can do 1 times 4 equals 4, 3 times 4 is 12, 6 times 4 is 24, and so on. The other thing you can do is that if your ratio table is correct, we can say that 3 times 7 equals 21. Well, if we did it by multiplication here, you can do the same thing here. 12 times 7 is 84. I don't know why I did that with my voice. All right, problem set is there. This is not multiple choice. Good luck.